So, good morning everyone. I am Rialyn C. Bamanto and I'm going to solve and discuss this problem, the formula of paired sample t-test hypothesis testing. So, the problem is, a manufacturing process claims to have reduced the number of defects in their products. To test this claim, the number of defects before and after implementing change is recorded. A random sample of 10 products is taken for both before and after the changes. The defects counts before and after are as follow. So, step 1, we are going to find the differences of each value which is after defects minus before defects. So, the after defects is 8 and the before defects is 5. So, we're 8 minus 15 is equals to negative 7. 10 minus 14 is equals to negative 4. 9 minus 16 is equals to negative 7. 12 minus 18 is equals to negative 6. 11 minus 12 is equals to negative 1. 8 minus 17 is equals to negative 9. 10 minus 14 is equals to negative 4. 13 minus 9 is equals to negative 6. 9 minus 13 is equals to negative 4. And 11 minus 16 is equals to negative 5. So, the second step is we are going to write our alternative hypothesis and our null hypothesis. So, for our alternative hypothesis, we are going to prove that means that reduce average number of defects as needed to achieve a second service level. So our alternative hypothesis would be our mean difference is less than 0. So that makes our null hypothesis to be our mean difference is greater than or equal to 0. So step 3, we are going to calculate the sample mean of the difference. So in calculating the sample mean of difference, we are going to find the average score of this data. So first, we are going to add the total of this number, which is total of negative 53. So, x bar d is equals to negative 53 divided by 10 is equals to negative 5.3. So, for our sample mean of difference, we are going to solve a standard deviation. In the solving the standard deviation, there are two methods to solve. The first method is to use the formula and the second method is use Excel. In using the formula, simply get the difference of negative 7 minus our sample mean of difference negative 5.3. So, to solve the standard deviation, this is the formula to solve the standard deviation. So, negative 7 minus negative 5.3 by the power of 2 plus negative 4 minus negative 5.3 by the power of 2 plus negative 7 minus 5.3 by the power of 2 plus negative 6 minus negative 5.3 by the power of 2, negative 1 minus negative 5.3 by the power of 2, negative 9 plus negative 9 plus negative 9 minus negative 5.3 by the power of 2, negative 4 minus 5.3 by the power of 2 plus negative 5 minus 5.3 by the power of 2. So, over 10 minus 1 is equals to 49.1 over 9 is equals to 4.1. 4.9. Or so in following the formula, we are going to arrive at the answer of 2.214 using Excel. So step 5, since we are testing if the mean number of defects after implementing changes is lower, we will perform a 1 failed test with our significant level of 5%, which make it 0.05. So our degree of freedom is n minus 1 equals 10 minus 1 is equals to 9. So looking at the t table, the value of this number is 1.833 since we are going to use the left tailed t-test, we are going to write the negative 0.833. After the getting t-value, we are going to solve our alternative t-value. So, calculative t-value, we are going to use this formula. This is the sample new difference minus n, and the new d divided by our sample standard deviation divided by square root of n. So, the sample mean of difference is negative 5.3 minus 0 divided by the sample standard deviation, which is 2.214 by our sample, and divided by 10 is equals to negative 7.57. So our calculative t-value is negative 7.57. So, step 6, which is conclusion. Since the test statistic in the critical region, we reject the null hypothesis. There is enough evidence to support the claim that the changes have reduced the average number of defects. Therefore, based on the given data and the conducted t-test, we can conclude that there is enough evidence to support the manufacturing process claim that its changes have reduced the average number of defects. Thank you.